Welcome to Advanced Science. I am Mrs. Tratner, and this lesson is what are your ideas about small sizes? And these are the objectives that we're covering throughout the unit. Our goals for today are to sort objects based on size and also to come up with our own definition of what is nanoscale. Alrighty, so let's review a little bit from last time. So what I'd like you to do is I'd like you to pause and select an answer, and then I will reveal the answer for you. Which is an example of scientific notation? The correct answer would be B. Remember that with scientific notation it has to be between 1 and 9. 10 meters equals how many centimeters? The correct answer would be none of the above. Remember, 100 centimeters are in 1 meter, so 10 times 100 would be 1,000. So there would be 1,000 centimeters in 10 meters. If we have 0.02 centimeters, how many nanometers is that? The correct answer would be 200,000. So D, none of the above. There are 10 million nanometers in 1 centimeter. So you would take that times your centimeters, and you would get 2 times 10 to the 5th power, which is not one of our answers. So it would be D, none of the above. Okay, so what I want us to think about throughout this lesson is what is nanoscale? How could we define nanoscale? And if you want to pause the recording here and jot down some ideas and some thoughts on that, please do so. Okay, so how small is a nanometer? And we're also going to look at some other small sizes. So if we start with something that we're familiar with, like a centimeter, and think that a bean is about the size of a centimeter. Okay, that's something we can anchor our brain to. And then if we take that centimeter and divide the centimeter into 10 equal parts, that's a millimeter. And a flea is about the size of a millimeter. And if we were to take that millimeter and divide the millimeter into 10 equal parts, that would be 100 micrometers, about the width of a human hair. And if we were to take that 100 micrometers and divide that into 100 pieces, that would be 1 micrometer long, about the size of a bacterium. Then take that micrometer and divide that into 10 equal parts, and that would be 100 nanometers, about the size of a virus. And take those 100 nanometers and divide that into 100 equal parts, and that would give us the size of a nanometer, about the size of a small molecule. Pretty small. So if we look at it in terms of scientific notation, okay, we can see that a nanometer is about a billionth of a meter. So if the meter were our base, okay, a nanometer would be 1 billionth of 1 meter. And you can kind of see the breakdown for some of the other micro units, like the micrometer and the picometer. Okay, so I want you to pause the recording and think about this and jot down some ideas about this. What are some objects that are smaller than a penny? And the objects that you wrote down, which of those objects would be considered microscopic, unable to be seen with the unaided eye? So think about some objects and come up with, like, oh, I don't know, 5 to 8 objects that are smaller than a penny. And of those objects, which ones will you not be able to see without the use of a tool like a microscope? So go ahead and pause the recording, jot down your thoughts and ideas, and identify the ones that you would need another tool to use, like a microscope, to be able to see. Okay, so now that you've come up with those, let's think a little bit about those things. Okay, and what we're going to do is we're going to use a link in order to sort these objects from the largest to the smallest. So 1 would be the largest object and 16 would be the smallest. The link is in Canvas. Okay, so, and it's right underneath the video. So you're going to want to use that interactive link to sort these objects from the largest to the smallest. And go ahead and pause the recording and take the time and do that. Now you may have noticed that you would have had to flip through a couple of the activities at the website in order to get to this. So you should have been able to put these in order from largest to smallest. And if something didn't fit into a square, then you didn't have it in the right order. So you should have it in order from largest to smallest, so 1 to 16. And if you didn't, just pause the recording again and then just give it another try. But you might have to flip through a couple of them in order to get to this particular activity. Okay, so think about this. Which of the images were the easiest to rank and why? And then which was the most difficult and why? Okay, so think about that for a minute and pause the recording. And then think about, how do nanoparticles like the carbon nanotube or the buckyball compare in size with a cell? Are they similar? Are they different? What do you think? And then finally, how do nanoparticles compare with atoms in size? So pause the recording, jot down some of your ideas on this, and then we'll move on. So thinking about what we've kind of gone through today in the activity that you did where you sorted the objects, how has your thinking about small sizes changed? And the instruments that we may need to use to see these types of objects, are they the same? Are they different? What kinds of instruments do we need to use in order to see these objects? And what do you think about it? What should we explore next? Are there other things out there in the world that we should be exploring? So take a moment and think about these questions and then resume the recording. So, life-changing. Nanotechnology, has it changed our lives? Some things to be thinking about as we continue to move forward. Now, what I would like you to do in your notebooks is I would like you to come up with a definition for the nanoscale. Come up with some information. What would be some keywords that you would use to describe nanoscale? What would be some examples and what would be some non-examples? So pause the recording and take a couple of moments to come up with a definition, some information, characteristics of nanoscale, examples, and non-examples. Now, if you do have questions, please make sure that you come and see me. Your assignments can be found on the calendar. They can be found in the modules. Okay? The one assignment that you do have is the investigation, cutting it down. And, now my strip of paper is a little bit smaller, okay, and I didn't cut it to the exact width, but you need to, okay? And when they talk about cutting it in half, they're not talking about cutting in half the long way, they're talking about cutting it in half this way. So you're going to fold it in half like this, and then you will cut it, okay? And then you're going to measure. And then you take the other half and then you fold it in half again and you cut it. And then you continue, you measure and you keep going. Okay, so like now I have 3 pieces. So I'm just taking one of the strips and I'm continuing to fold it in half and continuing to cut it and then measure it. Okay, if you do have questions about the cutting it down activity, please make sure you see me during office hours or through study hall. Okay, have a great day.